number 36. So y'all pause and read for a second, get some kind of thoughts on your own, and then let's look at it together. Well, the minute hand and the hour hand of a large clock on the top of the building have lengths of 710 centimeters and 506 centimeters. And I used this problem, gosh, one time a couple semesters ago, and somebody always told me, that's not really that large. Well, I don't know. We can't be picky. But we have, so the lengths of the hands are 710 and 506. So, and then we want to know the distance between the tips of the hands of the clock at 6:45. So this is definitely one of those unique problems y'all probably haven't experienced before. Well, let's first draw ourselves a picture. So we got a minute hand and an hour hand with 710 and 506. Okay, and it tells you first of all it's 6:45. So let's draw ourselves a picture. Here's the center of the clock. Now, since it's 6:45, I can guarantee for a fact that minute hand, we'll call that the minute hand, is right over there at the 9, right? Because it's right there at 6:45. Now, however, let me draw you something. If we say this is 6, this is 7, and this is 8 on our clock, we can't just say that the hour hand is straight down, because that's not 6:45. Because as that hour hand goes around as that minute hand goes around, remember it drags that hour hand with it just ever so slightly. So when we say that it's 6:45, really what we've found is that hour hand, instead of being directly down at 6 or being directly over 7, it's actually 3/4 of the way from 6 to 7. So it's actually kind of right down there. Okay? All right, now incorporating what our lengths are. We have 710 and 506 centimeters. And we want to know the length between the tips of these hands. So if that's x, in order to do the law of cosines, it says x squared is equal to sum of the other sides squared minus 2 times 710 times 506 times cosine of the angle opposite x. Well, the angle opposite x is right in there, and we don't know that yet. How can we get that angle? I'm going to ask you guys a question. And you've got a clock. There's 12, there's 6, there's 3, let's see, 9. Got to give myself my portions of it. Notice how a clock makes a full circle. So if I took a minute hand and I rotated it all the way around, you've gone 360 degrees, haven't you? And if I divided it up by hours, you've got 1, 2, 3, 4. In other words, you have 12 equal pieces. Well, 360 divided by 12 is 30 degrees. So that means to get that minute hand, when it goes from 12 to 1, it's rotated 30 degrees. From 1 to 2, it's gone 30. 2 to 3, it's gone 30. 3 to 4, and so on and so forth. Okay, so between 6 and 7, right here, I have 30 degrees. And because we're at 6:45, we've gone 3/4 of, remember, of means multiply, so we've gone 3/4 of 30 degrees. We haven't rotated a full 30 to get to 7, we've only gone 3/4 of the way. Okay, so 30 times 3/4 is 22.5 degrees, or if you want to consider what's left to still rotate to get to the 7 is 1/4 of 30. So 1/4 of 30 would be then the 7.5 degrees. Okay, so either way you want to look at it, I can either say my hour hand has gone a total of 22.5 degrees towards 7, or you can say I have left 7.5 degrees. Mainly because obviously theta is going to be made up of the 7.5. Okay, so what theta is technically the 7.5 that's remaining to get from the little hour hand over to the 7, and then to get from 7 to 8 to 9, we have a total of 30 plus 60 more degrees. Did y'all see that? So to get from the remaining hour hand to get over here to that line, and then from 7 to 8, and then 8 to 9 because we're at 6:45. So that'll be 30 and 30, which is 60. So a total, so that means our theta is 67.5 degrees. Okay. Plugging this into our calculator, and this time I'm going to go ahead and take the square root. And I get, round to 3 significant digits, so I get 833 centimeters. Look at that and see if that makes sense. I've got sides of 710 and 506. That looks like a pretty long measure between the two. So I'm thinking, right, it's about 833. Okay? All right, let's call one more problem and we'll call this finished. So number 40 in the book. Let's pause and read and we'll be finished. And this so happens to be the very, very last problem in the section. But a military ship is leaving its home and sails 278 miles in the direction of northwest to Island A. The next day, the same ship is going to leave A and sail 112 miles in the direction of northwest to point D. What is the bearing of D to port P, to its home? Okay. The printing here is kind of a little small. Let me see, that kind of looks like 6350. Let's call that 6350. That when the ship is leaving its port on port P, it's going to go 278 miles. What it's going to do is do it in the direction of north. Let's call it 63 degrees 50 minutes west to Island A. Okay, so let's draw that first. So we're going to go northwest 278 miles. Okay, 6350. Alright, so here's port P. It's going to give myself a bearing. So he's going to go north to the west, about right there. And let's draw ourselves a long side. The angle is 63 degrees in 50 minutes. And the side length is 278 miles. Okay, so from there, the ship is eventually going to say, we'll call that Island A right there. And the ship is going to go from there, again, northwest, ever so slightly, 8 degrees in 10 minutes. Okay, so I'm going to kind of run on through my work here. Maybe y'all can follow me on this. I was trying to get this accurate, but let's say we go right there. So that's Island A, and we're going to go up there, and it says this is 112 miles this time. And that angle right there is 8 degrees in 10 minutes. Okay. And we want to know the bearing of this final port, or this final destination, in order to get all the way back to our initial starting point. Okay, that's what we want to know. Alright, let me see if I can just give myself another picture just real quick so we can really see this. We're going to go all the way back there. That's that short angle AD, or 8 degrees in 10 minutes. And that was 112. And trying to get this accurate. I'll probably go a little bit longer with this. And that's 278. And then to get from here all the way over there, that was at 63 degrees in 50 minutes. Okay, and we want to know the bearing of D from P. So to get from here over to D, we just want to know this angle right there. That whole angle right from the line over, that is the 6350, but we want to know just to get to the line that would take us up to D. Okay, so it's obviously going to be from the north. We're going to go theta degrees west. All we have to do is find theta, and then we can call this one done. Alright, so let's look here. What information do I know, and what would I need to find in order to solve this problem? Well, if this line right here is parallel to this line right here, this 278 miles is what bisects these two parallel lines. So an angle that goes from the parallel over would be the same thing as this angle right here. So we can call that one also the 6350. And if this is 63 degrees in 50 minutes, and we know that this one's 8 degrees in 10 minutes, I can at least get this one right here. So that might help a little bit. So let's first find alpha. This is a straight line, so I know that alpha plus that 63 degrees in 50 minutes should add up to 180 degrees, because 180 degrees is a straight line. So alpha is 180 degrees. We'll go and transform it just a second. 179.60 minus the 63 degrees in 50 minutes. So really alpha is going to be 116 degrees in 10 minutes. Okay? And then that whole interior, because eventually what I'm going to do is get this side for a second. And that whole interior angle right there obviously is going to be 116 degrees in 10 minutes plus the 8 degrees in 10 minutes. So 116 plus 8 should be 124 degrees in 20 minutes. Okay, so that's all that interior angle, what that's going to be. Okay, so let me erase some stuff just for a second, and let's start thinking about what else we can do. Because really, we just need to be able to find just the theta there on the outside of that angle. Okay. Let's first get x. So x squared is going to be the sum of the other two. So 112 squared plus 278 squared minus 2 times 112 times 278. I'm getting to think why this is the last one in the problem in this section. And then times the cosine of that whole interior angle we just found, which is 124 in 20 minutes. So plugging this in our calculator, I get x to be 353.4, so we'll just round it up to this 353 miles. Okay, so I have x to be 353. Now, to wrap this up, if I can get this small angle in here, maybe this time we'll call it beta, then in order to get theta, all I have to do is take the 6350, subtract off beta, and then I'll get theta. So theta is 63 degrees in 50 minutes minus whatever beta is. And I can get beta through the law of cosines. Okay, so we're going to do law of cosines. I had to get that third side, so that way that my only unknown at this point that I had was actually just going to be beta itself. So now that I have it, then I know the side opposite beta, which is 112. So 112 squared is going to equal the other two sides now. So 353 squared plus 278 squared minus 2 times 353 times 278, and then now times cosine of that angle by 1, which is cosine beta. All right, so moving, the 353 over the 278 and dividing off that like we've been doing this whole entire section, let's go and get beta. When I do it myself, I get beta to be 15 degrees and 15 minutes actually. All right, so to finish this problem up, just plug in beta right there. So we'll get a theta by the time we do 63 minus 15. What comes out is 48 degrees. And 50 minutes minus 15 minutes is 35 minutes. So final answer, north, 48 degrees, 35 minutes west. Ooh, this was a long problem. So glad we're done. Ready to go on to the very, very last section of this whole book.